Hello, good morning, everyone. I want to welcome you to um revision section. This is going to be part two. We started on Monday, and of course, on Monday, I started walking you through some areas, the coverage areas for exam one. And of course, today we're going to continue from where we stop on Monday. Now, like I said, I actually, the midterm one, we actually cover these areas. Of course, you're going to have question on to explain or predict. You're going to have questions that we ask you to decide between a convex or a concave, giving some set of functions. And of course, I, emphasize, I think I said that on Monday, that there are two out of the clustering algorithms that we did in this class. Of course, you're actually going to be tested on two. One, density-based clustering, and the other one, the Gaussian-Mitchell model-based clustering. And of course, on Monday, the material that I walk you through Gaussian-Mitchell model. I also walk you through some questions on density-based clustering. I want to go into questions, likely questions on the, to explain or the material that I walk you through. I walk you through Gaussian-Mitchell model. I also walk you through some questions on density-based clustering. I want to go into questions, likely questions on the, to explain or predict. Of course, in this class, I started this class the other time, trying to make a distinction between explaining or predicting. There's going to be some questions like this. Take a look at this question now. Now that look like that. A retail store collects sales data over the past year and notices that sales increase significantly during certain holidays. The store management uses this data to understand the factors contributing to these sales spikes and aim to determine whether promotions, products, offerings, or external factors such as weather play a role. And the question asks, is this scenario focus on explanation or prediction? Justify your answer. If you want to answer a question like this in exam, I think one of the reasons why I'm trying to show you this today is for you to be able to know how far you go, like what is the expectation like. Okay, I needed to take a look at my response. I said the store management is attempting to determine why sales increase during specific time by investigating the contributing factors like blah blah blah, promotion or product offerings, external condition. And I said the focus is on uncovering causal relationship and understanding past behavior. Yeah. I told you the other time the difference between to explain or to predict. When you're talking about explanation, explanation, as a tension that has to do with going retrospective, looking backward. Looking backward, to be able to explain. You want to explain past behavior. And that is why I said the intention here is to explain the sales trends. Okay, and that's why the focus here is explanation and not prediction. So in exam, if a question that look like this come up, you don't just choose your answer. You don't just say to explain without you actually provide a reason. You got to provide justification for what you choose, just like the same way I did here. Does that really make sense? Is there any question on this before moving forward? Any question? Like I said, you don't just choose explain, even if explain is the correct answer, or if a prediction is correct answer, you're not going to get a full grade if you only choose without you providing justification for what you choose. Does that make sense to everyone? Okay, I want to go into another question now. A financial analyst is tasked with developing a model that forecasts stock prices for the next quarter. The model is built using historical stock data, economic indicators, and market trends. The goal is to determine the future price, okay, of stock to assist in making investment decisions. And the question asks, go ahead. Oh, thank you for that. I'm not asking question. I just reading it. Thank you for that. Thank you for so. And I said, is this scenario focused on explanation or prediction? Explain why. Now, take a look at my response. You know, I did not just say prediction. I'm actually going to give reason why. Because here the focus is on the future. I told you the other time, prediction is prospective. Prediction is forward looking. Does that make sense? And so, and that was why in the response here I said a financial analyst is tasked with developing a model that forecasts. What do I mean by forecasting? Forecasting is a scientific prediction of the future. Okay, stock prices for the next quarter. Okay, the model is built using historical stock data, economic indicators, and market trend. The goal is to estimate the future price of the stock to assist in making investment, decision. Okay. So, and I said the analyst goal is to use historical data to forecast future stock prices, which is an effort to predict what will happen in the future. Okay. We're not interested in what the role play by maybe economic factors, or we're not interested in all of that. We're actually interested in the future. Okay. That's why I said the model is focused on making prediction about future outcome rather than explaining why certain stock prices behave a certain way in the past. We are not interested in that. We're not interested in the contribution of factors, but we're only interested, predicting the future. Okay. Any question? And also I said, therefore, the scenario centered on prediction. Okay. Now, like I said, there will be questions on, on something like this, where you're actually going to choose. And when you are choosing, make sure you justify the reason why you choose what you choose. Now, in the last class, I walk you through density-based clustering algorithm. I show you, and I'm bringing it back again because I'm actually yielding to the advice of some students in the class that why can't you also bring a question that we're actually going to have a border point. The other time the question only have core point, no border point. Let me tell you this. I'm not going to guarantee that all the time, depending on the nature of data. You could have some data set, they're all going to be entirely noise. That's possible. And you're going to have a data set, they're all going to be entirely core point. And you could have a data set where some is going to be core point and some they're going to be border point. Okay, now I needed to pay attention to this now. And that was why we said the accuracy of density-based model. Okay, sorry, I think you need to cross this out. Give me 1 second. I wrote density-based density. So the accuracy of the density-based algorithm actually depends on the parameters. Don't forget the 2 parameters, the minimal distance and the minimum number of points. When I decide to change the minimum number of points and the minimum distance, there's possibility I'm actually going to have different clustering. Does that make sense? Now, based on what you are seeing right now, okay, the minimum distance is actually set as 2. The epsilon is set as 2. The minimum number of points is actually 3 here. Now, show how clusters and noise points are determined. You're given this particular data set, okay? And you know what? If you're given that data set, I think what I'm actually going to advise that you should do is to generate distance matrix. You know, if you generate distance matrix on this, you remember the other time I gave you a table? Maybe I got 1, 1, 2, 2. If you can do that, you're actually going to see the clear picture of what I'm talking about. 2, 2, 8, 8, 8, 9, and 25 and 80. So what I will advise you to do is to also write it here too. 11, 1, 1, 2, 2, 2, 0, 8, 8, okay, 8, 9, and 25, 80. If you do that, that will be fine. You know what you're going to have in the diagonal, right? Can somebody remind me? What are you going to have in the diagonal? 0, 0. Thank you so much for sharing. You know, if you can, because what if I ask you, I can ask a question like this and I say, okay, compute the distance matrix. This is what I mean. Okay. And with the distance matrix, it will show a clear picture for you to be able to know which of them will actually be in a particular clusters. Okay. You can see cluster 1, cluster 2, and the noise right now. And you will be able to know which one is at the border point, which one is at the. So I want to believe constructing distance matrix will actually work. So if you can do that, I want to believe you should be fine. Okay. So, and in my explanation here, I said step 1.11, you check, and so that's a core point. The other one, you check. I said expand the cluster from 1, 1 to include 2, 2, and 2, 0. 0.22 and 20 are border point because they don't have 3 points in there. Let me tell you this, before you can be classified as a border point, you don't have the minimum requirements to be classified as a core. And the minimum requirement depends on the numbers of minimum points required. Okay? And that's why, if you take a look at the one in cluster 1, okay, is different from the one in cluster 2, and is different from the noise. But a lot of, I didn't show you a lot of things. There's a lot here behind the scene. Don't forget, you're actually going to start by, using the Euclidean distance, computing the Euclidean distance, where you'll be able to generate the distance matrix. And looking at the distance matrix, of course, you can now start comparing, that with those that are within the neighborhood of, points required and the numbers of minimum point. Like I said, there's going to be exam question that's centered on this. And if I were you, sure, make sure you come to this exam with the calculator you can trust. You need calculator for that exam. Okay, the calculator you can trust. Okay, go ahead. Yeah, if you look at the cluster one, okay, how many coordinates do you see in cluster one? 3. That is it. That's a core point. Because to be classified as a core point, you actually need to be in a cluster. If to be classified as a core point, minimum it has to be 3. That's why you got 3. Exactly. The cluster 2 is border point. They have what? Yeah, but if you look at it from the angle from where you were, and that's why I said if you plot the what is it called, the distance matrix, it's not just looking at that particular value per se. If you start from, if you look at the way the data is, right, 1 1 2 2, if I want to start on the matrix board, I'm actually going to start from 1 1 this that. Okay, so, and let me tell you this, some people may want to argue that, like, why can't 5 be a core point? If you want to go by your argument, why 1 1 2 2 2 0 8 8 and 8 9 be a core point? But what happened is we also want to ensure to minimize the number of objects within a cluster. We don't want so many objects. And that's why here we are just like, okay, because, for manual computation, this is not likely going to be the set of data we're going to have in real life. There are going to be so many, right? And what you are now thinking about now, cool, like, oh, minimum number of points I can have. I can also have more than the minimum. But in this case, because how many coordinates of data set do I have? 1, 2, 3, 4, 5, 6. Does that make sense? And that's why we say, okay, let's completely emphasize on the minimum number 3 to be classified as a core point. Does that make sense? Yeah, go ahead. 2, 2, and 2, 0. Yeah, 1, 1, 2, 2, 2, 0, they are all core point. No, he said expand the cluster from 1, 1 to include 2, 2 and 2, 0, 0.222 and 2, 0, because they don't have 3 point. Yeah, when you look at everything in general in terms of cluster, in terms of explanation now, one can say, okay, looking at it relative to the, but the idea is I want to look at my clusters, like how many points am I going to have in the cluster, looking into consideration to the minimum number of points. I understand what you mean, and that's why at times one of the things that is confusing here is at times you could have core point that behave like a border point. You could have border point that behave like a popper. But in terms of putting them in a cluster, okay, here we actually want to identify how many possible clusters do we have and which one can we refer to as a noise. We all know that even before we go into this data set, we know 25 and 80 would be a noise. The only thing is just to, and I'm actually going to be left with 5 coordinates. And despite the fact that, I want you to see my point now. Let's say we settle for this. Because I've decided I'm not going to, if I'm going to give you that point, I'm not going to give you the one that's more than 6. Now, if you take a look at this now, let's say this guy is settled. That's a noise, even before we do anything. But how many coordinates do we have more? We got 5. Now, in principle, they can never be in the same cluster together because putting into consideration the samples, the number of coordinates that we have. So, because I know that the coordinates the minimum number of points is going to be 3. Okay, I can just say, okay, in cluster 1, I'm going to have that guy, and in cluster 2, I'm actually going to have 8, 8, and 8, 9. Another thing now, I want us to see another reason now. If you want to base it on average, because this clustering, they all work together. Now, if you look at 8, 8, and 8, 9, they shouldn't be in the same cluster with 1, 1, 2, 2, and 2, 0. You understand what I mean? So that is it. Yeah, go ahead. Oh, okay, say that again. Or, yeah, not all border points are core point, but we could have possibility at time where, core point can probably, because there are some core points that are also very close to border point. Okay, I'm going to give you this as an example now. Maybe a city in Minnesota that is very close to a city at the border. We have a border, right? And we have another city in the in the continental Minnesota, also close to, and that particular city may even be far from. So, and that's why. But you know what I'm going to do in this exam? I'm not going to, the way I'm going to grade the density based algorithm will be different, where I'm going to be open to so many options. Does that make sense? I will be open to so many options as regard this. Okay, I want to go to convexity. You know what? I will test your knowledge of calculus. I will test your knowledge of multivariate calculus. And what I need you to do, okay, you need to, you can see in this function now, you only see x squared, y squared. What of in exam, you see exponential, or you see natural log, if I were you? Or what of if you see a trigonometric function? So if I were you, I need you to revise your knowledge. How do we differentiate a trigonometric function? How do we do first and second derivative on sine s, cos s, and so on like that? And there's possibility you could have the combination of a trigonometric functions and maybe logarithmic function in a particular function, and I ask a question like this. So I will advise you should revise your knowledge of how do we differentiate trigonometric function, how do we differentiate logarithmic functions, and how do we actually differentiate exponential function, because the knowledge of that will be tested. But let me just give you this model, considering the following function. As you can see, I got bivariate, right? This bivariate, x and y. Okay, the logarithmic and the trigonometric function or whatever functions also going to be bivariate. Now, for each, determine whether it is convex or not using the gradient and Hessian matrix. Let me tell you this. Because there's so many ways to investigate for convexity, then I will be able to tell you the particular approach I wanted to use, just like the way I'm saying here. Now I said using the gradients and the Hessian matrix. The gradient will involve having the first derivative, right? And the setting up an Hessian matrix will involve you having to do second derivative. Take a look at this. Now this is what I expect. Then the gradient calculation, the first derivative, and the Hessian matrix. Then from what you see in the Hessian matrix, that you have a convexity test. I remember in the Hessian matrix, when the diagonals are positive, that's a positive definite. Positive definite actually translates into what I call convex function, right? What if I have, if one is positive and the other one is 0, you have a semi-positive definite. Semi-positive definite, even though it's a convex, but not strictly convex. I don't want you to lose any point. Make sure you give detail. And if you have, what if in a situation where you got a combination of a negative and a positive in the diagonal, of the Hessian matrix. Okay, so there's a way that could be neither convex or nor concave. But what if you are strictly negative? That would be a negative definite. The negative definite is not convex. Now, I need you to pay attention. What did I do first? I want it this way. This is a gradient calculation now. The gradient calculation is just talking about first derivative. And you can see here it's going to be a partial derivative because I got x and y for differentiated with respect to x. And I later differentiate with respect to y. Look at what I got for the three equations. And after that, I'm actually going to go into the Hessian matrix calculation now. And you can see in the Hessian matrix calculation, you can see the second derivative is required. When you take a look at the first function, of course, you can see here, the lead diagonal here is 6 and 4, right? Positive, positive. That's a positive definite. That is convex. If you take a look at this guy, the same thing here. But take a look at this guy here. One is negative, the other one is positive. Situation like this is neither convex nor concave. Take a look at that. And somebody asked me in my office hour yesterday, and I want to thank those who visited my office hour yesterday. And somebody asked, what if in a situation where I differentiated and the diagonal is in terms of a variable? Okay, you know, here you have a constant, right? What if in a situation where we have maybe this one is 2x, negative 2x, or maybe that one is 2y in a way? At times you could have situation like that where the diagonal may be maybe variable, and what you need to do, there's going to be a condition that you're going to impose. If you take a look at this guy now, okay, if x is 0, okay, if x equal to 0, that is the only condition. Let's say s equal to 0. Maybe you say s is equal to 0, or let me just say it's less or equal to 0. You know what I mean? If s is less or equal to 0, if s equal to 0, that guy is going to be 0. Negative 2s is going to be 0. If s is less than 0, that will be negative. That will cancel that negative, right? That will make that positive, right? Okay, and if y, and if you now impose another condition on y, that's y greater or equal to 0, that is the condition under which we can have converse here. So you are going to be the one that will impose a condition, because it could be anything. It depends on the condition you set. Does that make sense? So when you have it in terms of variable, you will be the one that will set that condition yourself. Okay, there's another example. And you can see when I was taking the decision under the convexity test. Okay, you see the way I was doing it. You know, at times in the convexity test, in addition to looking at the element in the diagonal of the Hessian matrix, somebody can say, okay, why can't we find the determinant as well? That's also okay, because we want the determinant to be non-singular. We don't want it to be singular. Now, that was why I said verify the eigenvalues of the Hessian, of the Hessian matrix are non-negative. Or alternatively, the one we've been doing is just strictly looking at number 1. Okay, but alternatively, you can check the principal minor of the Hessian matrix. But there are several approaches. Okay, and of course, we all see that when you take a look at this guy now, right? That was what I said. Eigenvalues is for both positive. Okay, then the conclusion is that is going to be convex. You can see I said f of xy is convex. Take a look at this. Look at this guy. 3 and 1 convex. But look at what I said about -2 and 2. Okay. I say it is not converse. I did not only stop there. I also said, since the Asian has both positive and negative eigenvalue, it is neither convex nor concave. Because somebody is going to say, oh, if it is not convex, it's going to be a concave. Not all the time. If it is not convex, it may not also be a concave. Depending on, when you have a mixture of signs in the diagonal of the eigenvalues, that is the decision you're going to take. Does that make sense? Is there any question at this time? For which question? Oh, yeah. Thank you so much. You're right. You're referring to this here, right? Yeah. Thank you for catching that. That should be 2, 2. Because from what we can see here, it's 2. Yeah, thank you for that. Okay, now I want to go into another, we're still under convexity. And I want to go away from second order condition to Jensen inequality. And I needed to pay attention. A question like this is going to come in the exam. Okay. Now, I also want to test your knowledge of Jensen inequality. Jensen inequality is a tool used to determine whether a function is convex. For a function f to be convex, the Jensen inequality states that, you remember the other time that we said a line, okay, on the segment connecting, x1 and x2 can also be, where the function of that is actually going to be less or equal to the sum of the weighted function. Okay, where of course the lambda here is actually going from 0 to 1. And you know what? If I provide you this in exam and I said check for convexity of f of s equal to s squared, if you use a second derivative here for me, then that person will score 0. Because you have to obey instruction. Instruction is asking you this time around, use Jensen inequality. Does that make sense? We are not using second derivative condition here. I want you to use that. Now, for f of s equal to s squared, and how do we do it? How do I expect you to do it? I need you to pay attention now about how I'm going to do this. I actually want to use that. F of s equal to s squared. Okay. And whenever you are given this, don't forget, you're actually going to go, you want to make use of the Jensen inequality. You actually need to want to make use of 2 point, x1 and x2. 2 point, x1 and x2. Don't forget, that's what we want to take. 2 point, x1 and x2. Now, what I need you to do, okay, we're making use of the Jensen now. I need you to pay attention to this. What am I actually doing right now? If you take a look at the right hand side here, right, and come back to the right hand side in the equation of Jensen for f of s, you see f of x1. Okay, this actually apply to a function of x. Okay, for function of x, we are only taking 2 point, x1, x2. Okay, now, but our f of this applies to a situation where we have f of s is actually equal to x, what you see in the standard formula. But what they are asking you to do is f of s equal s squared. So which means wherever I see x1, on the nomogram for f of s, if I want to rewrite this, or for f of s equal to x, this should just give me what? Lambda x1, right? Plus 1 minus lambda x2. What have I done? This is for situation where f of s equal to x. But you know what I'm asking you? F of s equal s squared. Then what are you going to do? That was why you get this. Now, when you take a look at that, okay, which actually means the whole of this, the whole of this guy is more or less like f of x. Please pay attention. The whole of that is more or less like f of x. If I want to make it, if I want to square that x now, because the f of s equal to s, if I square that now, okay, I'm actually, you're going to see what has happened. Lambda x1 plus 1 minus lambda s2 all squared. What if in a situation where they ask you to investigate for absolute value of x? Instead of squaring that, it's just going to be absolute value of that. Does that make sense? I need you to pay attention now. So the f of lambda x1 plus that is now lambda x1 plus 1 minus lambda s2 squared. Y squared. Because f of s equal to s squared. Look at it here. If I were you, why can't you practice for absolute value of x, or the log, or the exponential? You can try all of that. Now, the next thing I'm actually going to do is I just need to expand that guy. I need to expand that guy. I'm talking about the right-hand side. It's going to give me this. Is there any question? When you expand that guy, okay? And after expanding that guy that we have, that guy right now. Now, what we now want to do is to compare this with the weighted sum of the function values. Okay? We actually want to compare that. And you remember the other time, if you want to do this, if you take a look at what I have here, take a look at what I have here, which means for this part, right? I'm actually saying if I write, it means this guy, f of x1 is the same thing as what? X1 squared. Why? Because f of s equals s squared. So f of x1 will be s1 squared. What would be the f of x2? F of x2 will be s2 squared. Any question? You see that? Because f of s equals s squared. So f of x1 will be s1 squared. Now, after that, what I'm actually going to do right now is to check if the inequality hold. Now, I need you to pay attention. This guy, okay, is this guy. This guy is actually this guy. You see that? And don't forget, we are emphasizing on less or equal. Don't forget this less or equal. Now, if I rearrange and I simplify, okay, the inequality will be reduced to this. The inequality will be reduced to that, okay? And we now want to have a sense moving forward, okay? Under what condition can we have that to be less or equal to 0? We know, if I say less or equal to 0, which means that it's going to be 0 or negative. Do you see that? Under what condition are we going to have this guy here to be 0 or to be less than 0, which is to be negative? Okay? Now, the only way we can actually investigate that, four of us investigate the lambda and 1 minus lambda. Don't forget, lambda is between 0 and 1. That's positive, right? 1 minus lambda is also going to be positive, right? And lambda times 1 minus lambda is also going to be positive. Okay? Now, that guy is going to be positive. Okay, this guy. Okay? And when you take a look at x1 and x2, if you investigate the x1 and x2, okay? So the reason why this actually maybe may go maybe 0 or less than 0, because this particular entity here, like I said, does not have a way to be over 0, and I mean to be greater than 0, and I'm going to tell you why. Lambda is a fraction. 1 minus lambda is a fraction. When I multiply a fraction by a fraction, what do you normally happen? It goes down. Like 1 over 5 times 1 over 8 will be, the result we're going to get will be smaller than 1 over 5 and 1 over 8. Does that make sense? So lambda is a weight. How do I know lambda is a weight? Take a look at this. This is 0, 1. Okay. And it is only, let's just say, and the condition under which I'm going to tell you the condition under which you're going to get 0 exactly now. Put lambda to be 1. What do you have? 0. Put lambda to be 1. What do you have? 0. When you use the two extreme values, what are the two extreme values in the 0 and 1? If you plug in lambda to be 0, the whole thing will be 0. If you plug in lambda to be 1, the whole thing is going to be 0. But if you choose a number greater than 0 but less than 1, at the end of the day, that will give you less than 0. Does that make sense? There is no way you're going to go over 0. And because of that, we're actually going to say f of s, or s squared is converse. Is there any question? Go ahead. Actually, this is what happened. Just like what you said. I think it's better to be able to argue that using, I think the very first thing I would do, if I want to argue that, I'm going to say, I will start with when lambda is 0 and when lambda is 1. When lambda is 0 and lambda is 1, obviously that would be 0, right? And when lambda lies between 0 and 1, if I can actually have a negative, then I'm also, so I will first start my argument with the extreme value of lambda of lambda. Does that make sense? The 0 and 1. Because it's a weight. Okay? So that's a very good question. If I were you, I gave you a square now. Why can't you try exponential, the log, or you even try, okay, what difference does it make if I have s squared and if I have a negative s squared? If I have s squared and I have a negative s squared, don't forget, when the inequality change from less, okay, mathematically speaking, if I have an inequality equation and I multiply both sides by negative, what will happen to the inequality sign? It's going to change. And you all know, if it is not less or equal to, if it is greater than, that will be concave. You remember? If it is exactly equal, okay, that may still be a converse, but not a strictly converse based on what we've done before. We got some functions that have tendency to be I think affine function that can serve as that can be converse, that can also be concave. I think I just review. Let me tell you this before I go. I used to tell students this whenever